Yeah, okay. So I thought I'd just briefly talk about a secondary pollen presentation and self-incompatibility in plants. And it's something that shows the complexity of creation, not only in the complexity of individual organisms, but in the complexity of ecological systems that God has created. So just put that onto the next slide. So pollination in itself is a complex a system, and there's many different types of interactions between insects, birds, mammals, um, with flowers. Uh, you know, evolution struggles to find answers for why we have two sexes in the first place, let alone the array of different interactions between sexes in different organisms. And here we have an example of interactions between plants and animals in many instances. So there's an example there. You've got the vanilla orchid that is only known to be pollinated by a particular bee, even though these organisms didn't evolve at the same time. And in fact, there's some stats there. 65% of all flowering plants are pollinated by insects. Um, and there's particular things that attract the insects to the plants, and that can be color, it might be the actual scents, and food rewards in nectar and so on. So let's just put on the next slide. Part of my study, as I raised on a previous show, was about this little plant, and it's got a very interesting pollination system. Um, so if you see the little, it's called a pin cushion. If you see the little pins in the top of the flower, that's actually the female part, but it's actually displaying the male part. So if you go to the next slide, thanks, Sam. We're just going to work through this. This is one of the individual little flowers, and if you click a few times there, Sam, you'll see some of the labels coming up. So you got the petal there of the flower. Keep going. Yep, there's the anthers. That's the male part that holds the pollen, produces the pollen. The indusium, will come to that. Next one, and style. The style is the stalk that holds the female part, the stigma at the top of the, there we go, the developing stigma. Okay, now on the side of that little structure there called the indusium, you'll notice a bunch of hairs. Now, as we go through the next slide, you'll see as the style pushes up into the flower as it's developing, okay, there it goes. Those flowers start to catch the pollen, and they empty into the indusial cup, and then it keeps growing and up through the flower, next stalk, and there you go. You've got the pollen presented actually in the indusium, which holds the female part. Now, the interesting question with that is, why doesn't the pollen pollinate the female part? And that's answered by a self-incompatibility system. So each flower is incompatible to fertilizing itself. But interestingly, it will take pollen from a different flower. Well, this is really interesting. How could anything like that evolve gradually? And we'll come to some of those questions in a minute. So, Sam, if you go backwards, and let's just show the viewers this again, one after the other from the arrow. Yeah, from about there. Let's go up. Okay, just go steadily through that. Probably from there is the best starting point, but yeah, that's good. It's growing up again,
We'll go
pushing
from
up.
there. So then it's not.
Go forwards. Yep. There it's pushing up, and there it's presenting, and you can see that. Okay, so let's move to some questions that arise from this. First question is, why doesn't the pollen fertilize the stigma? Well, we've briefly mentioned that, the self-incompatibility system, and actually a lot of plants do have this. They can actually lose it in some instances. So put the answer up there, Sam. Sorry, I didn't have this organised earlier. So it has this inbuilt self-incompatibility system. So second question, are there any advantages in this system? Well, there are, because it forces, you can put the answers up, but it forces cross-pollination. There you go. And it also brings the pollinator, like the insect, directly to the female part. So if it's got pollen from a different flower already on the insect, then it's directly in contact with the female part and increases the chance for fertilization. The indusium, which was that little structure that held the hairs on the side of it, is like a protective cup, and if it rains, it reduces the chance of the pollen being destroyed and washed onto the ground. And it also restricts self-pollinating and therefore the inbreeding disadvantage that can result from that. Okay, are there any disadvantages? Well, the obvious disadvantage is that if there's fewer individuals out there, you've got a lower chance of fertilization occurring. But I think this is very well offset by the improved genetic diversity that results. Okay, and last question, how could this system possibly evolve gradually? And you can put the answer up there. Well, even though it's a question I asked, it's a good question. Nobody knows. All of those parts must work effectively from the very beginning for the system to work. Even from the hairs on the side of the indusium, you need something to get the pollen in there in the first place, just at the right time that the stigma is developing. You need to have the self-incompatibility system in place before the pollen is put on its own stigma, and you need the insects there to pollinate from one flower onto another flower and another plant. So this is just a brief example of a complex ecological system, and there's many of them out there, and I know Diane's quite an expert in some of these things in particular, and has probably presented some of these in the past.
So, I'll just add a comment here, Craig, because we borrowed you for our DVD on Darwin, right? Remember we stood up on the top of the big hill near your place in Tasmania where there was a patch of these, which you discovered, I believe. And so this is pretty rare. They're not everywhere in Tasmania, are they?
No.
Okay, so this is the discoverer of a patch of these plants. So he's pretty much famous world over in Tasmania, in his own town at least. So anyway, it was fascinating to note that absolute dependence on this mechanism that plant had. And I've noticed that all around the globe, and when we try to take plants off the globe. Now, I know you've probably never read up papers on beans in space, but they've actually taken plants in space, and their first experiments are almost hilarious, because some of the things that we don't even think about they come into play. So why do beans need gravity? If you've ever tried to grow a bean seed in the absence of gravity, the poor thing doesn't know where to go. Its roots sort of, they don't know where down is. The plant doesn't know where up is. So you end up finding, hey, there's way more things involved in just growing beans than having a bean seed or having soil or having water. You need things like gravity, which depends on planets, which depends on space. So you can't have a simple little bean unless you have a universe. And it goes way like that with the whole thing. Like even with your pollen shedding, if the gravity wasn't there, the pollen would go in totally different directions. So the rest of the system would be absolutely incompatible totally, just with the absence of gravity. So these are absolutely vital relationships. And Diane, you've seen a lot of them as well.
Yes, it's one of the things that we like to write about in creation research, because it shows there's not only design within individual organisms, so within individual plants and within individual insects or animals, there's also design at the whole ecosystem level. So God designed whole functioning ecosystems. Nothing would finish, nothing would work until that was finished. So it had to be done quickly. Otherwise, we know what the life cycle of a lot of these plants are. I'm not sure what it is for this particular little flower, but I'm sure it's not all that long. So it all has to work within the life cycle of this particular plant. And there are some plants that have very, very short life cycles.